Hi, my name is Samantha.
And I'm Julia.
And today we'll be covering Chapter 5, Section 2, Definite Integrals. The general form of a definite integral is the integral of f of x from a to b dx. F of x is the integrand, b is the upper limit, and a is the lower limit. Basically, it's the area under the curve f of x from x equals a to x equals b.
An example of a problem where you would have to use definite integrals would be finding the area under the curve 3x squared between -1 and 5. And this is how you would write the problem as a definite integral. Today we'll be teaching you how to solve those types of problems.
The main methods of solving definite integrals using Riemann sums would be where you are given n as a whole number and you would have to approximate the area using n number of rectangles, or you would need to find the limit of the sums as n approaches infinity for the actual area. N would represent the number of rectangles you used to split up the area, and as it approaches infinity, you would be approaching the actual area under the curve. Thus, using the limit method would be more accurate. Another possible method would be to split up an integral into multiple individual integrals and solve each one by using areas. You would choose the method depending on the problem.
If the problem is asking to solve with n equals 6, you would be solving for the area under the curve by splitting the region into 6 rectangles and getting an approximation rather than the true value. So with n equals 6, your delta x, your change in x, would equal b minus a over n, where b equals 5, a is -1, and n is 6. So this would give you 5 minus -1 over 6, which equals 1 for your change in x. Problems like this can ask you to use right endpoints, left endpoints, or midpoints. However, we are going to be using right endpoints for solving this problem. Since our change in x is 1, x1 equals 0, x2 equals 1, x3 equals 2, x4 equals 3, x5 equals 4, and x6 equals 5. Okay, so this is what r6 would equal, and in plugging things in, we get 1 times f of 0 plus f of 1 plus f of 2 plus f of 3 plus f of 4 plus f of 5. And then, so that would be 1 times 0 plus 3 plus 12 plus 27 plus 48 plus 75, and gives us a final answer of 165. A common mistake would be to find the wrong endpoints, like other than what the problem is asking. So make sure that when you're finding your xi values, pay attention.
Instead of finding an approximation, we'll be finding the actual area by writing the definite integral as limit as n approaches infinity of the sum of f of xi times delta x between I equals 1 and n. So delta x would equal b minus a over n, and xi would equal a plus I times delta x. And delta x for this problem would equal b, which is 5, minus a, -1, all over n, which would equal 6 over n. And x of I would equal a, which is -1, plus I times delta x, which is 6 over n I. So rewriting this as a whole would be limit as n approaches infinity, sigma n I equals 1, f of xi, which would be -1 plus 6 over n I times delta x, which is 6 over n. From here, you could take out the 6 over n, and write it in front of the sigma, which would be limit as n approaches infinity of 6n times sigma f of xi, which would be plugging it back into the original equation, 3x squared. So you would write 3 times -1 plus 6i over n squared. So now that you have plugged in delta x and f of xi, we can expand this further into writing limit as n approaches infinity of 6 over n times n sigma 3 minus 36i over n plus 108 I squared over n squared. Continuing on, you'd have to use your sigma notation rules to further simplify your equation. So from here, you'd have to take the limit as n approaches infinity of 6 over n, and here you'd have to split this up. Sigma 3 minus 6 over n and finally you'd have plus 6 over n times sigma of 108 over n squared I squared. At this point, you would need to know your summation formulas. For I, it would be n times n plus 1 over 2. I squared would be n times n plus 1 times 2n plus 1 over 6. And I cubed would be n squared times quantity n plus 1 squared over 4. So in addition to using our summation formulas, you need to know that if you have a constant, you take that and multiply it by the variable on top. So you get limit as n approaches infinity of 6 over n, 3n, minus 6 over n, and now you could take out the 36 over n like we did before with the 6n, times 36 over n, and use your summation formula for I, which would be n times n plus 1 over 2, plus 6 over n times, take out the 108 over n squared, and use your summation formula for I squared, which would be n times n plus 1 over 2n plus 1, or times 2n plus 1 over 6. From here, you would just continue simplifying, and you'd have limit as n approaches infinity of 18 minus 108 times quantity n plus 1 plus 108 times n plus 1 times 2n plus 1 over n squared. And since this is a limit problem, you don't really have to distribute fully. You just have to know that these would all cancel out, and you'd get 18 minus 108 plus 216, which would be 126 as your final answer. So in this problem, there are many mistakes that can be made, and a common one would be forgetting to write your 6 over n, and just make sure you have it throughout the problem. Also, make sure that you're writing limit as n approaches infinity for every step so that your teacher knows what you are doing on the test.
So this is another example problem, and for this one we use the final method that we talked about in solving definite integrals. So there's a property of integrals saying that if you have an integral composed of multiple different functions, for this we have 3 different functions, then you can split it up into individual integrals. So we would have this. So there's another property of an integral that says that if you have something that's like cx, you can move the constant to the front. So this would become this. And so now we can solve the problem by finding the areas of each of the individual functions. So for this, we can use x instead. It would form a triangle, and it would be 1/2 times 3, which gives us 9/2. And then over here we have this function is a circle, but since we're going from 0 to 3, we have a quarter circle, and that gives us 9 pi over 4. And then over here it's just a rectangle because the line's 7, and then from 0 to 3. Okay, so now we can add all of these values together. Remember that since for this one we found it for x, not for x, so we need to multiply 4 by 9 over 2, and then plus 9 pi over 4 plus 21, which gives us a final value of 39 plus 9 pi over 4. Alright, that's it for definite integrals.
Thanks for watching. Hopefully this video is helpful.